water absorption does not just occur in the large intestine. This is just where I'm talking about it. And the large intestine does play a decent role in it. So first, let's go over where this happens and then how. So first of all, where is water coming in and going out? So you are eating and drinking. So from food and drink, you get about 2 liters. This is in a day. You have digestive secretions. Actually, let me do digestive secretions over here. That's really the other place where water is entering the digestive system. We're not talking about entering the body. Actually, we're talking about entering the GI tract. The digestive secretions would include saliva, all right, I want to talk about water absorption. This is something that doesn't just come into play in the large intestine, but large intestine is one place where it's important. So first, let's talk about where water enters the GI tract. Now, I'm not talking here about entering the body, but the GI tract itself, right? Which is actually technically outside of the body. So how does fluid enter and exit our GI tract? We can eat and drink. This is about 2,000 milliliters a day. We're just gonna look at everything over a day. We've got various digestive secretions. This includes saliva, gastric secretions, liver secretions, so bile, pancreatic juice, and actually I'm gonna write bile. Pancreatic juices, intestinal secretions, and that is our main, one more, mucus secretions from the colon. These, you can see there's already numbers written in my intestine there, so you could do the math. I'm not going to test you on the math. So by the time we get to gastric, we've got these 3 components added together. Bile, pancreatic, and intestinal are going to add another 4,000 milliliters to get to 9,000. And then what do we have left? Our mucus secretion is just about 200 milliliters. However, you can see here, what do you think these pink arrows are? We're going to have absorption. This water is going to be absorbed. Not technically, I guess technically it's reabsorption for the digestive secretions because you're taking it back into the body. But since it was an exocrine gland, it actually went out. Let's not worry about that. We will talk about reabsorption in the kidney. This is absorption. The small intestine is going to do a lot of absorption of water. About 7,800 milliliters. Large intestine, so colon, is going to absorb about 1,200 milliliters. Less than the small intestine, but still significant. If you do the math, you actually end up having about 150 milliliters lost in the feces, which makes sense, right? There's some fluid in there. There's some fluid that's lost in your feces. Okay, so the small and large intestine are responsible for water absorption. Does that make sense? And how does this happen? Yes, it makes sense because water is going to just follow the solutes down a concentration gradient. If we have high solutes inside of the intestine here, and those solutes are being absorbed, so let's say this is glucose, it's lots of stuff in reality, it's going to the bloodstream, water follows that down its osmotic gradient. This is osmosis. So water moves by osmosis, following solutes by the movement of those solutes. So you can actually draw this on your epithelial cell, right, where we had absorption, and we did that process of what transporters are needed for glucose to move through, right? There's three different proteins there. You actually could also draw in aquaporins, which facilitate water movement. Water moves both by facilitated and simple diffusion, but it's going to follow this glucose movement across the cell. So this can result in, right, your digestive system needs to absorb water. Diarrhea is when there's too much fluid in your feces. If things move through too quickly, then not enough water can be absorbed. So that's a homeostatic imbalance related to water absorption. The other thing I want to touch upon in a little more detail is the gut bacteria. And when I say touch on this a little more, I'm going to tell you just a couple of things about it. So the gut bacteria are thought to be important for chemical digestion. They are going to ferment, so that they contain enzymes. These are bacterial cells, right? Digestion. They're going to break down food. Lactose is thought to be something they break down and aid in our chemical digestion. Along with this, they also can synthesize vitamins. So vitamin K, biotin have been shown to be synthesized by these gut bacteria. Huge area of research. There's like thousands of bacteria in your gut. Key role in not just digestion, but overall health, other disease and stress. So this is an extra credit opportunity for you that would be really interesting.